Hello everyone, today we're going to be talking about set notation. So a set is a collection of things, which is usually going to be numbers, and we can list each element or member of a set inside curly brackets like you see down below. So right here we have a set of numbers, and these three dots right here kind of tell us that our set is going to go on forever. So there's a lot more items in this set, okay? So these members, they could really be anything. We could be talking about people within a set. We could be talking about items within a set. Most of what we look at will be talking about numbers that are within a set. So some commonly used symbols that we're going to see, these are called curly brackets, and that just means that we have a collection of elements. Okay, and those elements could be numbers or anything, okay? Next one is union. So if you ever see this symbol right here, we're going to take everything in set A, everything in set B, and we're going to unite them. And we want all elements that are either in set A or set B. So keyword here is or, okay? In order for an item to be in the union, it only has to be in either set A or it's in set B, okay? Next thing is intersection. Whenever you see this symbol right here, that means intersection. And then here, we're looking for the elements that are in both set A and set B, okay? So keyword here is and. In order for an item to be in the intersection, it has to be in both set A and set B. The last symbol we're going to see is complement, okay? And there's two different ways this could be written. You could see an apostrophe, or you could see a C as an exponent there. So whenever you're looking for a complement, you're looking for the things that are not in set A. So we're going to list the things that are not in set A if we're trying to find the complement. So here's an example, okay? So right here, this symbol right here is telling me that I want the intersection of these two things. Okay, and then keyword here is and. So in order for something to be in the intersection, it has to both be in set A and set B. Okay, so let's just look at set A, and starting with this 3 right here, okay? Is 3 in both set A and set B? I don't see a 3 down here, so we're just going to cross that 3 out, okay? Next thing, we're gonna look at 5. 5 is not in both sets, so we're gonna cross that out. 6 is in both sets, so 6 will be in the intersection. 7 is not. 8 is in both. 9 is also in both. 12 is not in both, okay? So I don't have to look at the rest of the numbers that are in set B because they're definitely not in set A. So the intersection of these two sets would be the numbers 6, 8, and 9. So that would be my intersection. Okay, here we are looking for a union, okay? And whenever you're looking for a union is or. So I want all things that are either in set A or they're in set B. So we're just gonna take all these numbers that we see up here and we are gonna gather them, all right? So starting with 1, okay, and then 4, and then 7, and we want to put them in order from smallest to biggest. And this would be the union of those two sets. And I'm just going to run through this and make sure I got them all. So I've got a 1 is taken care of, 4 is down there, I put 7 in there, I put 8 in there, 9 is down there, and 11 is down there. So this would be the union of these two sets. Okay, here's another problem. Here it's asking for the union of the two sets. So what I'm looking for is what in set A or in set B. So key word here is or. Okay, so the list of numbers that are either in set A or set B would be 2, 4, 5, and 6. And we're just trying to gather all the numbers that we see there. Here's another one. We're looking for the intersection of these two sets. So in set notation, that would look like this: A intersect B. And remember that this is and. So I want everything that's in set A and it's in set B. So we've got 1 in both. We see 3 is in both. 5 is not. 7 is not. 9 is not. 12 is not. So the only two elements that I have here are going to be 1 and 3. Those are the only things that are in both set A and set B. And then complement. So here for the complement, we're given a universal set, okay? So universal set just means that these are the only items that we care about, okay? So we're only looking at the numbers 1, 2, 3, 4, 5, 8, and 9. We're kind of pretending that that is our universe. That's the universe. That's the only items that exist to us right now, okay? So if I want the complement of B, I want to know what is not in B. Okay, so we know that 1 is in B, so I don't want that one. I know that 4 is in B, and I know that 9 is in B. Okay, so the items that are not in B would be everything that's left over here. So that would be 2, 3, 5, and 8. That is our complement of set B. And here's another example, basically the same thing. Again, we want what is not in set B, okay? So here we have, so 1 here is in set B, 4 is in set B, 5 is in set B, and 8 is in set B, okay? So everything's actually in B, so there's nothing remaining in the universal set. So we could just do this right here. That's one way that we could write that. So you say nothing remaining. That's one way that we could write that. Another way that you might see this written is this right here. Okay, just saying that there is nothing there. Okay, so that's it.